Along with curve fitting in statistics, there are two more important topics called correlation and regression. I mean, those two things decide quantitatively, not qualitatively, quantitatively how uh, two variables or more than two variables are correlated to one another. Okay. And then regression also, like how we have done in curve fitting, we plot lines of regression. Okay. Using the concept of regression. Okay. Right. Now, before understanding correlation, there's something called covariance that you have to understand. Of course, all of you would be aware of variance as well. Okay. What is variance? Variance of a variable x is nothing but usually if I have frequencies, I mean grouped data, I'll be calling it fi x minus xi minus x bar whole square by summation fi. Okay. Actually, this can be written in a more easier way, which would be nothing but e of x square minus e of x whole square. E of x is nothing but mean square is there. E of x square would be nothing but summation x square. Of course, fi is there first now. So summation fi x square by summation fi. Okay, that I will be taking. E of x square minus e of x whole square would be an easier version for variance to find variance and all. Now coming to covariance, how one variable is varying with the other, it is denoted by CO x comma y, guys, which is nothing but again, of course, in this terms only, in this terminology only, I am writing E of x minus x bar into y minus y bar. Okay. Of course, I can go with the expansion. I mean, multiplication of the inner terms. Xy minus x bar y minus xy bar plus x bar y bar. Okay. Now, we all know that expectation is linear. That means what? E of, I'll just write here just to recollect. You know it, but just to recollect. E of ax plus b is nothing but a into e of x. Expectation of a constant is itself. Suppose if I write the same thing for variance, guys, variance of ax plus b would be nothing but a square into variance of x. Variance of a constant would be 0. You ought to know about these two important properties. Of course, few more are there about expectation and variance, but then these are the basic ones. If you understand them, I think it would be more than enough, right? Now, so to see, clearly I can see in this formula, constant is taken out. E is expected to, expectation E is applied to the variable. So if I do the same thing, X and Y both are variables in the first term. In the second term, X bar is nothing but mean of X. So which would be a constant. So X bar can be taken out and I can write E of Y. Minus in the second term, again, Y bar is the mean of Y. So which is a constant. So I have to put expectation only to a variable. And in the last term, I can see X bar and Y bar, both are means only. So both would be constants. Mean would be a number, right? So I need not apply expectation for it. I mean, expectation of constant is itself according to the properties, right? So E of x comma y, x y would be there. Now, E of y would be nothing but expectation of y would be nothing but y bar only, na? Mean of y only, na? E of x is also nothing but x bar only, na? So accordingly, I'll be replacing x bar y bar minus y bar x bar plus x bar y bar. Okay. So x bar y bar is there twice with a negative sign. So E of xy minus 2x bar y bar plus x bar y bar. 2 plus minus 2 plus 1 would give me minus 1. Okay. So E of xy minus x bar y bar. What is x bar y bar? It's expectation of x and expectation of y, as I have written in the previous step. So I can write it like that just to maintain that uniformity. Okay. Right. So covariance of x comma y is nothing but expectation of xy, x into y, minus expectation of x into expectation of y. Okay. This is the formula. This is the formula for covariance. Why do I need covariance? If you ask me, Why do we need covariance? Of course, again, covariance is linear from the properties of covariance. Let me, in this flow, finish off writing the property of covariance as well, so that there are no doubts. What would happen if it is applied and all that? Covariance of covariance of covariance of, okay. Okay, I'll just stop here and then talk about correlation and regression in the next video.